So, good afternoon. So, today we will be discussing the common mistakes in SPC. Okay, number one is we ignore SPC. So, what does this mean? We are just using SPC for show. Because the customer asks us to do the SPC, then we just do it. We ignore any information that the SPC is trying to convey us. Okay? Number two, we confuse specs limit with control limits. Take note, guys. There are two limits that we can see in the control chart. So, here it is. The USL, which means the upper specs limit, lower specs limit, and the upper specs limit. These limits are given by the customer. This can never be changed, okay? These are the customer requirements. While the control limits are the upper control limits and the lower control limits. These are the limits that is the voice of our process. Okay? It's not the voice of the engineer rather. Okay? So this is based on our historical data, not based on any engineering knowledge. Because if we use the engineering knowledge in putting the upper control and lower control limits, it can be misleading in terms of actions that we put in our process in times we are having trouble. Okay? So this should be coming from our historical data. Okay? There are also two terms, the target and the center line. The center line is actually the line or the limits that is between the upper control limit or the center of the UCL, which is the upper control limit, and the lower control limit. The target is the center of the upper specs limit and the lower specs limit, which are the customer requirements. Okay, usually if our process is not skewed or is not skewed to the right or skewed to the left, or there is no there is no skewed to upper side or skewed to the left or skewed to the right, then the target is approximately the same with the center line. Okay? Okay. Number three, monitoring the wrong parameter. Okay. So this is very critical, guys. How do we monitor or how are we putting up items that we need to monitor? Okay. We have the customer requirements, right? They are giving us the requirement. The customers are giving us the requirement. Based from these requirements, we need to identify the key process output variables. Okay. Like for example, the customer requirements tell us the thickness should be 30 to 90. Okay. So this is just an example, guys. So the thickness should be 30 to 90. Okay. So of course, we need to monitor this as part of our KPOV. Okay. And what are the things that we need to consider in our KPIV also in order to control this requirement? Okay, so we need to identify the leading indicators, okay? If I say leading indicators, what are the parameters or what are the KPIV or what are the KPIVs that is directly impacting our KPOV item? Okay, so this one, the critical items here are those items that have directly impact in our KPOV. Okay, so we need to identify all the KPIVs. This is our process. So those KPIVs are those that we input in our process in order to meet the KPOV or the customer requirement result or the product that we are producing. Okay? So these are the KPIVs and these are the KPOVs. Okay, there are items that is potentially measured here, controlled here, the KPIVs, which are the customer requirements, and there are also items that we need to control here in the KPIVs. So it is very important that we need to understand our process before putting up or before identifying a parameter to monitor or to control. Number 4, wrong calculations of control limits. Okay, control limits, there are rules in calculating control limits. So I will separately do some discussions on this. Okay, but wrong calculations of limits or control limits is misleading, guys. We need to be dependent on the data that we are gathering. We don't need to put engineering knowledge on this because the process itself not cannot convey to us or cannot give us the information by talking to us. So this is very dependent on our SPC monitoring. Okay, so wrong calculations of control limits is misleading. Okay, so maybe at some point we are encountering troubles in our process, and then we add or we put and implement corrective actions na hindi naman pala kailangan. That is not needed. Okay, so this one we need to be very cautious in calculating our control limits. Number 1 rule that I need to emphasize in calculating control limits should be calculated using the data that is only coming from common cause of variation. The data should be free from any outliers. Okay? Before calculating the control limits, we need to check first our data. It should be free from any noises. Okay? Okay. Number 5, no out of control rules activated. In SPC, there are rules to be considered. Okay? Because if there is no out of control rules, our SPC monitoring is no use. That is why the reason why we are using SPC is that it will be used as a trigger for us, and the activation of out of control is very essential. Okay, so there are rules that we need to consider. Number 1 is 1 point outside the upper control limit. So there is point here outside the control limits and the lower control limits. Okay, why do we need to consider this rule? Because if our process have this out of control already, it's nearing the specs limit already. That is why the use of the control limits is our guard. This will guard our process for any potential issue that may lead to not meeting the customer requirement. Okay? So, that is why if ever we have points outside the controls that we have implemented, we need to take action and understand why we have this. And definitely, we need to provide a corrective action. Okay? Number 5, no out of control rules activated. So this is done. Running tools despite repeated OOCs. This one is not different to number 1. Okay? We ignore SPC. Because despite repeated OOCs already, we are not intervening. Then what is the use of our SPC? It's just for show because the customer asks us to do so. It's not the thing. We need to be very vigilant in terms of the OOCs in our SPC. That is why we are asked to have OCAP. Okay? What is OCAP? OCAP is out of control action plan. This is to address all the OOCs that we are encountering in our process. Number 7, engineer ownership of SPC chart rather than operator ownership. Why this one is written here, one of the common mistakes? Because the engineer is not 24/7 dealing with the machine that we have. The operators are the one dealing in our machines. That is why we need to empower our operator in reading, in understanding our SPC, not only the engineers. Okay? The operators need to understand or need to have knowledge in terms of our SPC because they are the 24/7 dealing with our process, not the engineers. Engineers come with 8:30 to 6 p.m. only. Okay? So, that is one misconception. Number 8, too many charts created. Don't plot for plotting's sake. We usually this. Because, of course, we want to cater the customer requirement. We plot and plot. There are many monitoring that is happening in our process, but we don't know what is the essence why we are monitoring it. We don't know how to interpret. Too many charts created. Don't plot for plotting 6. It means we are just collecting and collecting data without any analysis, without any checking on what is happening on our SPC or in our process, because the SPC, guys, is the voice of our process. This is the way of our process to communicate with us, because our process cannot communicate it with us. Take note. Okay? So, the next topic that I'll be going to discuss to you is more on control charts. So, I will be discussing more on control charts on the next video. Thank you.